analysis. Additionally, attendees will also be introduced to the Scapy module, which is a powerful packet analysis tool in Python, enabling automation and simplifying network tasks. Participants will learn about Scapy's functions, including packet filtering, extraction, reading, and network statistics analysis. And finally, the session will conclude with an introduction to Nmap. Nmap is a renowned port scanner and its usage in network scanning. So as excited as you are to attend today's webinar, we request you to maintain the same tempo, not only for the CTF participants, but for everyone else too. The next webinar on the topic would be Network Attacks and Defense, which would be helmed by another technical expert from Cisco, Mr. Harikrishnan Jayachandran. The schedule for this is, as already announced, on Friday, 9th June, 3:30 to 5 p.m. You can access the previous webinars on the CySecK website as well as on our YouTube channel. I'd like to request all of you to please subscribe to our YouTube channel. It will help all of you to get to know when new recordings are out, and it will help us to gain better traction and visibility. Let us now get into the specifics of today's webinar and understand the scheme of webinar and assessment. So first we have the webinar number 57, which will be delivered by the speaker, Mr. Akshay Dubey. And there will be a link to the assessment, which will be provided at the end of the webinar. Like I informed earlier, I will paste the link to the assessment, which is delivered through Google Forms in the chat box for those who are attending this through WebEx. And for those who are joining us through the YouTube live stream, we will paste the link in the description. However, all of you are requested to please remember that the assessment shall be open for 60 minutes only post the conclusion of the webinar. And it's possible that you might get a few questions for webinar feedback, which would be qualitative and quantitative in nature. We try to collect some data about the kind of experience you've had. If in case you do get these questions, please answer them as truthfully as possible, because they will help us a lot. Since this is through Google Forms, we request all of you to please use the Gmail ID to take the assessment, and do not use multiple mail addresses per participant. This is extremely important for all those who have registered for the CTF. Participants who score 10 or more answers correct out of 19 will be eligible for the award of a certificate. So this will be a certificate for the particular webinar itself. This will be a certificate signed by the center head of CySecK, and it will mention the topic of the webinar and will be applicable only to this webinar. So let me now introduce our technical expert for the day, Mr. Akshay Dubey. Akshay Dubey is a senior technical leader at Cisco Systems India Private Limited, and he has 12 years of experience in the field of network security. He has worked on a number of security products like next-gen firewalls, network access solutions, and on different types of VPNs. He is passionate about solving customer problems and has presented his work and his research at various forums, various industry and academic forums, including Cisco SecCon, Cisco Live, the Association of Computing Machinery, ACM Winter School for Cybersecurity, the Null Community Bangalore chapter, and at various universities all over the country. He holds a CCIE security certification. I would now request Akshay to please unmute, turn on his video, and to share his presentation. Yeah, Akshay, am I audible? Okay. Control room, Akshay has to be unmuted, please.
Yep, I am
The
unmuted
control
now.
room.
Thank you. No, I am unmuted now. I hope you can hear me.
Yeah. Yeah. Yes, Akshay. I think you can come a little closer to your microphone, please.
Okay. Is it better now?
It's much better now.
Okay. Thank you very much. Thank you, Abhishek sir, for the introduction. Let me quickly share my screen, and I hope it is visible now.
Yes, Akshay, it is visible.
Okay, great. So, give me 1 second. Thank you, everyone. Thank you for joining this webinar. It's actually very exciting whenever we see young folks joining, because it makes me remember my college time when I was actually very enthusiastic about um, these trainings, these type of sessions, right? So with that, so this first session is on network analysis and tools, where we will discuss a bit more on what are the different network analysis tools, how a network works, and since there are so many different participants and there are so many, uh, so we have a very different set of candidates who have joined this webinar, right? So we will try to take it from as low level as possible, and we'll move on to go into much more details um, of each of the topics. And let's see. So I hope this session will uh, set up a platform for you to go ahead and learn further more into the field of the cybersecurity. So with that in mind, I'll just start something about me. I think Abhishek sir has already told all these things, so I'll not spend much time on this. And here's a quick agenda, right? So today we'll discuss about what is a network, the details of the network, then what are the different layers in a network, what is Wireshark, why it is used, how it is used, what are the different networking protocols that we use. Then we'll focus on the crafting tools like Scapy, and then the network scanning tools like Nmap. So with that, let's start with a very basic thing, right? What is a network, right? So a network is nothing but it's just a collection of interconnected devices. So these interconnected devices could be computers, routers, switches, or any other devices that are linked together to facilitate the communication and data sharing. Now, these networks could be wired or wireless. By wired, I mean that you have devices connected via Cat5, Cat5e, Cat6 cable, or it could be a coaxial cable. They were in earlier days we used to use T1, T2 links. And then it could be over a wireless network as well, right? So this wireless network is um, everywhere now. If you go to the airport, if you go to the railway station, everywhere you will see that or a coffee shop, wherever you go, you will see they are providing the wireless networks wherein you can connect through your mobile phone and access the internet, right? So over the network, so once you see over the entire internet, right? So the entire internet, it's a collection of devices. So when you access google.com, so your request for google.com goes through your ISP through a multiple hops. Your ISP is nothing but it's a collection of routers and firewalls through which the traffic goes through. And all these combined together form what we call as a network, right? You use WhatsApp. I believe every one of you use WhatsApp, right? So when you send a message from one phone to another phone, that also uses the network. Now, there are different types of networks. We call they are LAN, WAN, MAN, right? So LAN is a local area network. So a network which is within a very small range, that we call as the local area network, just like a small office or your home, right? And then we have wide area networks. So wide area networks cover a larger span areas. Now those larger span areas, let's say my company has offices in multiple countries. Now I can communicate to a server which is located in a different location in US for my company. So this is an entire wide area network, right? Then we something call also call these some as metropolitan area networks, which are basically for cities. Now with the recent, and if you consider recently you might have heard there is a shift in the network paradigm where people are moving towards the cloud. Now, cloud also is a network. So it is nothing but a bunch of devices, but which are hosted in a data center, which you don't manage. So with that, so here's a simple example, right? So this is a very simple example of a very simple network. So this is what you see day to day in your home, right? You might be having a wireless router or a modem through which you connect your phone. Might be multiple phones are connected through which you connect your laptops, and you might be connecting your smart TVs through it. Some of you might have Alexa and all, and you connect your Alexas through those wireless routers. Now, this is an example of a very small network, right? Your wireless router will then connect to your internet, and that can through which you access your various websites, right? Now, network can be as complex as this, right? Over here, we have multiple devices, multiple nodes, hundreds and thousands of nodes deployed all over the world, right? It could be for an organization, it could be for an ISP, but this is how complex a network can get. Going from a small home network with a few devices to as many as hundred thousands of nodes. Now, what are the different layers of a network, right? So how do two devices communicate? So let's say you have two machines and you want to make a communication between the two machines. Then how does that communication work overall, right? So there's something called as the OSI layer model. Now, what this OSI model says is, so it's an open system interconnect. Now, it provides a guideline on how the communication should happen so that everyone can build a network in a similar way. Everyone can develop protocols in a similar way, such that these communications can happen, right? So you might have studied in your engineering college. At my time, um, there was a subject on computer networks. Now, in that computer networks, we read about OSI layer model. At that point, I didn't understood much about what that is, apart from writing that up in an exam. But in real world scenarios, when it is actually used, you will be able to you will be able to appreciate it more, and you will be able to understand that in a better way why such things happen, right? So we have application layer, transport layer, internet layer, Ethernet layer, and then you have a physical path. Physical path is nothing but your physical cables which connect the two devices together. Now we'll go up through each of these layers to understand what is present in each layer and why each layer is important. So the first thing which we have is the application layer. So application layer is nothing but how your application will communicate. So let's say you are accessing, let's say a web page, right? So web page, let's say google.com or facebook.com. So Google or Facebook, so when you make that request is basically an HTTP request. Now we'll get into more details about what an HTTP request is. But when you make that request, when you make that HTTP request, so HTTP becomes your application. Now HTTP runs on top of a layer 4 protocol, which is TCP, which is the transport layer protocol. So TCP TCP is a connection-oriented protocol. I hope so just for folks who are not aware, so TCP is a connection-oriented protocol that provides a reliable, ordered, and error-checked delivery of data between the applications. So you establish a virtual connection between two machines over a specific port, and then you transfer the data over that port. So TCP is basically more reliable in the sense that if there is a network loss, if there are packet drops in the network, it overcomes that. It takes care of those. So there is basically flow control is there, and there is an error recovery mechanism. And then you have UDP. UDP is a connectionless protocol, which is basically used wherein you need better performance. And then you have below the TCP UDP, you have layer 3, which you call as the internet layer. Now this internet layer is where your IP addresses reside. Now you might all be on your laptop or a phone, right? So all your laptop or phone on a network, they will have an IP address. That is how your devices will communicate. That's how the traffic goes from your phone or your laptop to the internet. So IP address is nothing, but it's just a 32-bit field. So this 32-bit field uh, takes care of identifying the network, identifying these your device over the network, and it knows how to route the traffic. Right? So then you have, so when I say route the traffic, so you might have used Google Maps, right? So if you have to go somewhere from one place to another, you just mark the starting point, you mark the end location, and you follow the path what the Google Map shows you. Right? So your end destination is nothing but an IP address of the destination. So in networking terms, if you think about it, it is the IP address of the destination, the path which it follows, right? So these are nothing but the routes which are there in between. So the ISP knows the routing. ISP will tell you that, okay, for in order to reach this destination, this is the route which it has to take. And it will keep on hopping between the routers and it will reach the destination. And then at layer 2, we have something called as the MAC address. So MAC address is nothing but a built-in address. It's a burnt-in address, which is globally unique. And that's how it's a 48 bits mask. And what it does is it uniquely identifies your machine. So all these, if you see, I have marked these end to end. So whenever the communication happens between two machines at the application layer and at the transport layer, this is an end to end communication going from one machine to another. Whereas at the internet and the Ethernet layer, it is a hop by hop. When I say hop by hop, that means in order to reach from your source to the destination, there are multiple hops, multiple routers, which it has to take, right? So your devices in between routers in between will look into the internet layer, that is layer 3, and layer 2, that is the Ethernet layer. So if let's say if a communication will start from the application layer, from this device to this device, it will, at the first hop, it will go into the router, it will be read up to layer 3, it will go back onto the physical path, it can go onto the second router, it will be read up to the layer 3, and then it will move onto the other device, onto the other destination. So this is how your actual communication will work. So when the second device will receive the traffic. So when the first device is sending the traffic, it goes from application layer down to transport layer to IP to Ethernet and then to the physical path in terms of bits and signals. And once it is received on the other end, it goes into the Ethernet layer, which is your MAC, which is the layer 2 here. And then layer 2 is stripped, it will read into the IP address, then it will go into and read the transport layer, and then it will go and read the application layer. So this is how the communication will work from one machine to another machine on different layers. Okay. Now, with this, you might have heard a lot about the client server model. So client server model is it is something which is very commonly used. As and when we'll go into more examples, into more details on the protocols, you will be able to understand it more better. But just to give an understanding, right, this. So client is nothing but a device which connects to another device which responds to that request. So the device which responds to that request is the server. Now, when you are accessing Facebook.com or Google.com, right, your browser is the client from where the request is initiated, and this Google.com or Facebook.com is the server which responds to that request. So as you can see in this example, the client has initiated a connection to a server on port 80. Now port 80 is nothing but a HTTP port. So it's a web server port that's for HTTP. Client initiates a request. When the client initiates a request, it uses a ephemeral port. We call these as ephemeral ports. So the port range is from 1024 to 65535, because any ports below that are reserved port which are used for all known services. When the client initiates a request to the server, it goes through the network. The server receives the request on port 80. It understands the request, and then once a connection is established, there are two sockets open. So one is we call as the input stream, the other one we call as the output stream. So the input stream on the client will connect to the output stream on the server side, and similarly the output stream on the client will connect to the input stream on the server, so that there can be a bidirectional communication. Now, the advantage what we see with the client server model, right? Because since it's a centralized system, so server is a centralized. Now, it doesn't depend on the client. There can be one server and there can be thousands of clients, right? So all the programming, everything, whatever is stored, right? Whatever the heavy duty stuff that is stored, that is all stored on the server side, so that the client can remain. It doesn't have to do a lot of processing. Now, since it is a centralized system with all the data in one place, it's a more cost efficient, because you have to focus only on one part on the server side. And the capacity of the client and the server, they are not directly related. That if you need more capacity on the server side, you can increase it independently of the client side. Now, the disadvantage of this client server model, right? So if something has advantages, if also has disadvantages as well, right? So all these clients, right? So clients are prone to viruses. So when we say prone to viruses, let's say when you are connecting via server, it will not be just a known legitimate server. You might have seen those. So during college days, I used to download a lot of free software, right? And the challenge was always to identify what was the correct link to download the software, because there will be 10 if you are going for any free software. So in this world, nothing actually comes for free, right? So when you go for a free software, there will be 10 different links which says that uh, click to download the software. While it is possible that one of them is an actual link from where the software is downloaded, the other 8 or 10 may not be the links where actually the software is, but it might be trying to push something else onto the client, right? So this is where the clients are prone to viruses and worms. If the server is present, if the server has some viruses or it is trying to share some worms to the client, then it is possible, right? And let's say um, from the server perspective, right? Servers are prone to denial of service attacks. Now, if I have to bring down a server, I can simply send in a lot of traffic or try to identify something which crashes the server. So servers are prone to denial of service attacks as well. So there are remedial mechanisms as well. But in general, this is one of the things that has to be taken care of, right? Now, since it is a client server model, so the data is transmitted over the network. Since the data is transmitted over the network, there are chances of phishing or capturing the login credentials, more like a man in the middle attack. You can actually capture the data and modify the data before sending it to the client side. So all those things. So these are the ways in which the attacks also happen. Right? Some of the attackers look into the streams which are flowing between the client and the server. They try to hack into those streams, snoop into that data, try to eavesdrop into the data, try to identify if there is anything suspicious there. And on the basis of that, you can, uh, if there is something in that, and on the basis of that, it can maybe inject something into that stream and um, affect the client. Now, so I wanted to cover the protocols, but before that, I will go into the Wireshark. What is Wireshark? How it is used? What it is all about? Because then you will be able to understand better on what the protocol is. Because then we can dissect each and every protocol through Wireshark and better understand what are the different fields there. So for that, I'll just share a Wireshark screen. So Wireshark is nothing. It's a packet. It's a network packet protocol analyzer. It is probably one of the best which is available in the market. It can help you to capture the data as well as it is used for analysis. We very frequently use Wireshark because we troubleshoot network problems. So having a Wireshark, having knowledge of Wireshark in order to understand the network packets is actually very beneficial for us. We look into the details of the packet. We try to identify what is happening in the stream, what type of data is being transmitted, and accordingly we try to diagnose the problem, right? So if you have to download Wireshark, it's very simple. You can just Google for Wireshark. You can just Google for Wireshark, click on download, and as per the system specification, you can download the appropriate version, and then you can utilize it. And installation is pretty simple. It's just a few clicks and you will install the Wireshark field. Now, let's see means what are the different fields, what are the different options which are available, especially for those who have never worked with Wireshark. So maybe if you want to do, you can just simply download Wireshark and just follow along. So for Wireshark, so there are different options which you see here, right? So this is when you open the application, this is how it will look like. Now, first thing which will capture your, which will immediately capture your attention are these interfaces. Now, these interfaces are nothing but all the NICs, all the virtual NICs which are available on this machine on my laptop itself. So as you can see, this is the Wi-Fi interface. So Wi-Fi interface, and if you see some of these heartbeats which are going through, right? So what they indicate that there is a network activity that is going on across this interface. Now, if I have to capture the traffic, what I can do is I can simply click on this and it will start capturing the data on my NIC, on my network interface. Now, so if you can see here, right, so there's a lot of data. Let's open another capture just for this. Okay. Okay. Now, when you open any capture in the on the Wireshark, right, you can take it on your laptop and then you can analyze it, what type of data is being sent. So what it does is that it basically captures the traffic that is flowing through the network interface card of your machine, right? So you can take it on the network or you can take it on your laptop, whatever it is. But it basically how the packet is seen on the network, that is what it captures. Now, if you look into this Wireshark window, there are a few very prominent things which you will see. The first thing is the top half of the screen. What it is showing you is the packet summary, like what is the source address, what is the destination address, what is the protocol used, and some info about what is there in the packet. So this is the top half of the screen. On the bottom, there are two sections. This one we call it as the packet detail section. Now, packet detail section, where you can expand these packet details to look into each and individual headers of the protocol. So let's say for IP protocol, right? For IP protocol, you have something called as version. Right now, this machine was using IPv4. So that is where it is showing you version 4. Then it will show you the header length or if there are any DSCP fields. So if you compare this with the IP header, if the IP protocol specification, you will see it as it is. Like what are the different fields, what are the values of the different fields, like what is the TTL value, what is the protocol, what is the layer 4 protocol which will be used, what is the source address and destination address. So by expanding individual fields, you can get the details of the packet. So, and the other section is this one. This one we call it as the packet bytes. Now, with the packet bytes, we mean that, let's say this is a GET request for a downloading something. Now, what exactly is there in that GET request, or what is the hex dump of that, of those details, right? All those things you will get in the packet byte section, right? So this is the ASCII part and this is the hex dump part. So you can do it, you can show it as whatever, as bytes, as bits, but if this is as hexadecimal is something which is more better. You should be able to understand it better. Right? Now, what are the different things, right? So first thing, let's discuss on few of the fields which are there on the top. The first one is the sequence number. So the number is the sequence in which the packet is captured. The packet, when I ran the Wireshark, what was the sequence in which the packets were captured? Now the second one is the timestamp, how the packet, when exactly the packet was captured. You can actually uh, see it in a different format itself. So if you go under view time display formats, um, and you can just change it to seconds since first packet was captured. So it will just show you the time when the packet was since the start of the packet, what was the difference between each captured packet, right? Or if you just change it to, let's say, date and time of the day. So what it will do is it will change whatever was the timestamp in the caption. It will change it to the timestamp on your laptop. So it will automatically convert, it will automatically normalize the timestamp, and it will show you the time when it is as per the time zone of your laptop. And then the next thing is source destination IP is something which is very evident that it shows you what is the source IP, what is the destination IP. Then the protocol, what protocol was used for individual packets. Then what was the length, a brief of the details about those packets. Right. Now on top you will see few options. So one is this, so which says that automatically scroll. So let's say when you're taking a live capture, what this option does is it will automatically keep you to the last packet. Then we have something called as colorize options, right? So each of these packets will have a specific color in Wireshark, right? So that you can better understand, better identify, right? So by using this colorize option, basically you can go into the problematic section of the capture much more quicker because those are highlighted in a different color. And then this option here, it basically realigns the packet properly to the screen so that it is better visible to you. Now let's say for this IP, right, I want to see IP ID of all the packets along with it, right? So what I'll do is that under the IPv4 field, I'll go into the identification field. I'll just apply this as a column. Now what this will do, it will create one more column for me wherein it will list down all the IP IDs, right? Similarly, if you have multiple, if you're troubleshooting something or if you're trying to identify and you want to see that as a column, right? You can simply go ahead and just apply that as a column and then you should be able to see that. So that gives you a better visibility in terms of what that field was there in all the packets, right? So rather than going individually into each packets and going into those details, you can basically apply that as a column and view it for all the packets at the same time, right? Now, another important thing which is very commonly used is this filter option. Now, when you're taking a capture on a network, right? So especially for all these network forensics, whenever the capture is taken, the captures could be in worth of gigabytes. There would be there could be millions of packets which are there in the capture. Now, your task should be to first narrow down what you want to look into those captures. For that, we commonly use something called as the display filter. So let's say I want to look into all the HTTP requests. So I'll just put in a filter for HTTP and it will just show me the HTTP packets which are there in those packets, right? So out of those 43 packets, only 4 were HTTP, 4 were there, which 4 HTTP requests were there. So it just showed me those 4 packets. Now, we have something called as follow TCP stream, right? So let's say I have identified that, okay, this was the packet. This is what was interest for me. So what I'll do is I'll just do a right click. I'll do follow and just do a follow TCP stream. Now what this follow TCP stream will do is we call these as the tuples. So tuples is nothing but a combination of source IP, destination IP, source port, destination port, and protocol, right? So when you follow a stream, it uses these as a combination and it will filter down all the packets in the entire capture which match that criteria. So in this case, since I filtered for that particular TCP stream, what it did, it filtered out from that entire PCAP file. It filtered out only that specific data, and it showed to me this in the ASCII format, what it is showing it. But if you close it, it will just show you those packets for that stream. So if you see tcp.stream EQ0, so I didn't know whether it was stream 0, 1, 2, 3, 4, but you look into that specific packet, see if you want to follow that specific stream, entire stream, then you can just follow TCP stream and it will give you this entire, the captures only for that tuple. So if I, let's say for identification, let's say I put in, let's say a source port filter, flyers column and a destination port filter. Now, if you'll see all these packets, they have the same, the source port is 3372 and destination port is 80 in one direction. In the other direction, the source port is 80 and the destination port is 3372. So it basically filters all the packet with these combination of source and destination IP and these ports, and it will show you, so that you investigation can be narrowed it down to a specific set of captures. Now, there are a few other things which are actually very helpful when you are working on Wireshark. That is, let's say from statistics, you go into the protocol hierarchy. Now, what this protocol hierarchy shows you is what are the different packets and what are the different protocols in that entire stream or in that entire capture file. Right. So if you see here, so all of them are Ethernet, 100% packets of the Ethernet, which is layer 2. Out of Ethernet, 100% of them are using IPv4. That means there is no IPv6 traffic. There is only IPv4 packets which are there. Now, at layer 4, we have UDP as well as TCP packets. So 4.7% are TCP, are UDP, and rest 95% packets are TCP. And within UDP, you have DNS packets, and you have within TCP, you have HTTP packets. So what this gives you is more like a summarized view on what all different protocols which you are seeing on the network, and that will help you much more focus it or narrow it down your investigation. Right. Now, apart from this protocol hierarchy, you have something called as conversations. Right. We have something called as conversations. Now, conversations is also something which it gives something similar, but you can look into more details of, let's say, for TCP, between this source to this destination, how many packets were transferred, how many bytes were transferred, how many transferred packets and bytes were transferred from B to A, and how many bytes were transferred, and what was the duration, and what was the speed, what was the download speed, at what speed that conversation happens. So let's say you're downloading a file from the internet and that file download is slow. So maybe you can take up the captures and through that you can identify the actual download speed, and that you can use to troubleshoot the network problems. So this is one thing, and you can actually graph down all these things as well. So if you go under statistics, TCP stream, you can use any of these graphs. So let's say Stevens graph. You can actually graph down the speed of the download, that how much data was transferred between how much time. So if you see on the y-axis is the sequence number, on the x-axis is the time. So as the time passes by, how much were the different sequence, what was the rate of download in terms of how many bytes were transferred, because sequence number in TCP indicate that how much data has been received so far. Right? So you can utilize these utilities. So there is a lot more to Wireshark than this. It's more like a skill that you learn over a period of time. The more and more you'll start looking into the captures, the more and better you will be at it, right? So focus some time on learning Wireshark. What we will do is that we'll now go through some of the protocols, and then we will understand through Wireshark what are the different things which we are seeing for a specific protocol, right? So, okay. So this is DNS. So DNS is something which it is domain name system. A lot of you might be aware. So what this domain name system, what this DNS does is, so it provides a host name to IP address mapping. Now, what this host name to IP address mapping means is, say you are accessing google.com, or you access in a day, you access hundreds of websites, google.com, facebook.com, twitter.com, and whatnot. Right? Now, as I mentioned initially, right, when we read more about how the network communication happens, we read about we are I told about the IP addressing, that each device is identified with its IP address. Now, when that communication has to be established, eventually it gets established on the IP address itself. But for as a human, it is very difficult for me to learn numbers, right? It is very difficult for me to learn number that the IP address is, let's say, some 200.150.10.20, right? So that IP addressing, it's very difficult to remember for different, let's say you're accessing 100 websites. You cannot remember the 100 numbers, right? But we as humans are very good at remembering names, right? If I'll ask you to give me 10 websites, you will give me in an instance. But if you'll ask you to give me 10 phone numbers, right, it might be a bit difficult for you. So what this DNS does is it basically maps, performs that mapping, right? So there are DNS server, there are resolvers all over the world, DNS servers all over the world who have that entire mapping of the host name to the IP address. And when you make a request, to the DNS server, so let's say on your laptop itself, since you know that there is Wireshark, and on your laptop itself, just try to access facebook.com and keep the captures running and then filter the DNS traffic. You should be able to see what request was made. So if the first request goes to the DNS server, the DNS server will reply back with the IP address of the actual web server. And then the connectivity is made from the from the your client from the browser to the web server. Right? So there are this DNS works on UDP port 53 by default, but it also uses TCP port 53 under certain conditions. That is for now out of the scope of this discussion. But DNS queries, so they can be recursive or iterative. By recursive, we mean that you contact a DNS server. That DNS server didn't have the answer. So what it gives you the address of another DNS server, which can provide you that information. So then you contact that DNS server. That DNS server gives you that information back, whether it has the answer or not. If it doesn't, then it provides the information of the next level DNS server. And with iterative, what we do is that it is basically you contact a DNS server, that DNS server doesn't have the answer, so it will contact something else, then it will contact something else, and eventually it gets the answer. Right. Now, from the packet capture perspective, how this actually looks like, right? So let's say, let's open the DNS packets. So there are different types of DNS requests, right? So for simplicity, let's consider a simple DNS packet. So I have highlighted one packet. So if you see here, it says DNS query and this number is A. So what A specifies that I am requesting the DNS server to provide me an IPv4 address for this host name, right? So this is what we call as a type A query. And in response to that DNS query, there is the DNS server response with an IP address. So that will be an answer. It tells me that it is an address and it is located here. And then my client will make a communication to that DNS server. Now, without DNS server, you can consider the whole internet as dead, right? If DNS won't work, probably the internet won't work at all for you. So, and then you have something called as quad A query. Quad A query is nothing, but it is requesting for an IPv6 address. So the response for a quad A query will contain an IPv6 address. So IPv6 address is a 128-bit address. So which is used since there are shortages of IPv4 addresses. So we now use IPv6 addresses as well, but the migration is still, it is not completely, the internet is still not completely on IPv6. IPv4 still has a very major chunk of usage, right? Apart from that, there is something called as the MX query, right? So this is the mail exchange query, DNS query. Now this mail exchange query, basically what it does is, so um, when you have to send any emails, right? When you have to send any emails, that is where mail exchange queries are used, right? So this is a mail exchange query for Google. In response to that, we receive what the SMTP server details for the uh, for Google, right? So these are the different types of queries. So this, you can take the captures in your network on your laptop, and then you can understand it better, how the DNS protocol works, what are the different fields of DNS, right? With that, we'll just move on to the next part. With after DNS, we have telnet. Okay. So what is telnet, right? So telnet, it's another network protocol, but what it is, it allows you to remotely access the devices. So now sitting here in my office, I can access my devices which might be present in a different part of the world. So if I have to control that device, if I have to configure a specific device, I can basically configure it sitting here remotely. So it establishes a remote connection. So telnet, if you can see here from the OSI layer, if you see it in the diagram, right? Telnet client and telnet server at the application layer. So that is the application part. Now, at the lower layer, what it does, it uses is at the transport layer, it uses TCP. By default, it uses TCP port 23, but it can be, means you can use any port. Port 23 is the default port. But one of the challenges with, but it has some inherent security risks, right? Because telnet is not encrypted. Even the credentials which will be shared, right? Let's say if you have to log into a remote device, even the credentials that will be shared, that will be, those will be unsecured. If you take a capture on the network for a telnet traffic, you will be able to see all the data in clear text format, right? Because it's a simple text-based form protocol. Now, since security is of paramount importance these days, so telnet is not very often used. But the reason why I'm telling you is that if you see such protocols in the wild, right? So that gives you an opportunity, but that there is something on the network that can be snooped upon, right? So I don't think I have captures for telnet, but okay, let's move on to something called FTP, right? So FTP is nothing, as the name specifies, it's a file transfer protocol. So FTP works on port 21. It is very commonly used, very majorly used in many enterprises in order to transfer the files. So if you recall that client server model, right? So FTP also is a client server model. DNS also uses that same client server model. Your telnet also uses that same client server model. So FTP client first establishes a connection to the FTP server on TCP port 21. Once that connection is established, it exchanges the username, password, and what it wants to do, right? Let's say I have to download a file from the server. So there is something called as control connection, and we have something called as data connection. So control connection by default is on port 21, and data connection for active FTP uses TCP port 20. Right. So what that does is, so once the control connection is established, the server initiates the data connection on port 20, and then the file transfer happens. So to understand it better, right, let me just quickly open the capture. So this is a capture which I have taken. Let's say, okay. This is a capture which I have taken in my lab environment. Okay. So if you, in that way you can see, right? So it's all private addresses. So what it does is, so as I mentioned, that it uses TCP port 21. So TCP always uses something, TCP always, so whenever a TCP connection is established, we first do a three-way handshake. So if you see SYN packet, SYN-ACK, and ACK. So first the three-way handshake is completed. Once the three-way handshake is completed, that is where FTP application kicks in, and it will start sending out more details. So if you can see here from these captures, right, you are able to see the username as well as the password for the FTP server, which signifies that FTP by default itself doesn't provide any inherent security mechanism. This FTP itself as well is a plain text protocol. There is no encryption that happens. Now, after the login is successful, I would like to download a specific file. Now, in order to download the specific file, what it does, it enters into a passive mode. So this was a passive FTP. So there are two types of FTP. One is active FTP and passive FTP. In active FTP, the data connection is initiated by the server side, whereas in passive FTP, the data connection is initiated by the client side. So in this case, this is a passive FTP. So when it is entering into a passive mode, what you will see here, it gives me details about what port should be used for the passive communication, right? For the data communication. So here it shows passive port 2027. Now what I can do is I can simply filter this traffic TCP port 2027. Now it will show me the entire communication which has been done in order to transfer whatever file that has been transferred, right? If I just simply follow this TCP stream, right, it will give me list of a bunch of files, right? It will give me list of files what has been transferred, the files which have been listed, right? Now, let's say I transferred one file also here. This was demo. Okay. So let's say it is entering passive mode. Okay. So it says that it has transferred. Let's see if I can follow the stream. Okay. Now, when I followed that stream, it gave me this. This is a demo file created for CySecK. So this was the actual file this is the content of the ASCII file which I transferred. So what I can do here is I can just change it to raw and I can just save this file, right? So let's say if I save it, let's say I save it on the desktop. Let's say demo.txt. Now, once I open that file, it will give me the exact content of that file. Now, when I save that file and I'm opening it, it gave me the exact content of the file. So this was the exact file I transferred using the FTP. Right? So this is what you can do. This is how you can look into the details of the packet. Right? Now that let's move on to the next part. So this is FTP. Now what we have next is the HTTP. So HTTP is a very commonly used protocol. You use it day in, day out, but you may not realize it. So the entire World Wide Web is dependent on HTTP. You access, let's say any website you are accessing, right? That is accessed over HTTP protocol. So it's a request response model, again, client server. So you make a request from the browser. That request is received on the server side. The server side sends out the response. So we have a session which will be presented in a few weeks' time, wherein you will get more details and in-depth details about HTTP. So I'll not spend a lot of time here, but I'll just show you this HTTP capture as well in Wireshark just to give you a start. So let's say I have a HTTP request. Now, what this HTTP request will show you is the details of that HTTP transaction. If you see, it is destination port is 80 and then it is the get request. So once the three-way handshake is completed, then it sends out a get request. So this get request is how the server will understand that what type of data is being requested. So over here, it is requesting for a file called download.html. In response to that, the server will send out a 200 OK. You might see that 200 OK somewhere. You see here. So you see that once it sends out the entire data, it will send out a 200 OK. That 200 OK basically signifies that entire data has been transmitted. Now HTTP also is it's not a secure protocol in itself. We use something now when you might be accessing Facebook and all, right? You might have seen on the top left corner, it says HTTPS and it gives you a certificate. So by default, so this HTTP is basically used within HTTPS nowadays. Majority of the internet traffic is encrypted. Basically, we use certificates to encrypt the data, and that is so in order to prevent any eavesdropping onto the network, right? And there are more protocols. There are HTTP2 and HTTP3 also have been introduced, and they provide a better performance, multiplexing, and more enhanced security. Now, since we are on this point of Wireshark, let's I'll like you to introduce to a website which is called as Pico CTF. So Pico CTF is basically one of the organization where you can see a lot of CTFs getting organized. They also have a playground. So if for students like you, right, who wants to learn more and more about on how to enhance your skills or how to participate in CTF or how to learn about CTF, you can go and register on Pico CTF, and you can just go into their training ground. It is free of cost, and that will give you a lot of CTF exercises, right? And those CTF exercises will help you. So this is what it is, and those CTF exercises will help you enhance your skills, right? So went into this. So if you go into the practice side, so this will show you all the categories of CTF. But for this session perspective, since we are focusing mostly on Wireshark, so that comes under network forensics. Within forensics, there are few you see challenges. So let's do one of those and see. Let's try to do one of the challenges to understand how it looks like, right? So let me first open the challenge, say what it says. So this is Wireshark do. Okay. And what it says is, can you find the flag? And then it gives a link for a capture file. So what you can do is you can click on this, it will download the file for you, and then you can open that up in Wireshark, right? So what was that? Okay. Second, just give me a second. Let me quickly validate I'm on the right file. This should be okay. Now, so this is the capture. This is the capture file which I got, right? Now this capture file, I don't know. So there was no hint or anything on the CTF page. What it says is that can you find the flag here, right? Now, in order to find the flag, what I will have to do is that I will have to investigate this capture. So this is a very basic level of capture. So what you have to do is first you have to understand what are the different things which are there in this capture file. So if you go under statistics and protocol hierarchy, right? This will give you some information regarding what type of data is being transmitted in this capture file. So again, everything is IPv4. Then you have TCP. Within TCP, there are only two things. One is TLS, one is HTTP. So TLS is basically encrypted. So the other thing of which is interesting for me is HTTP, right? So what I'll do is uh, I'll go and just filter for HTTP. So let's see what are the different HTTP requests. And if you'll see here, there are a lot of HTTP requests that went through, and many of them are getting 200 OK, but they have a encrypted session, right? Boundary is encrypted. So if you'll scroll down further, just to see what are the different files which have been transmitted apart from this. Let's see. Okay. So over here you see for this one, it is just a text file, right? There is no data here. If I scroll down, I see some text here. There is something which has been uh, sent over this session. So what I'll do is I'll simply right click on this and do a follow TCP stream. Okay. And now when I did a follow TCP stream, what I see here are the details of the protocol. It's a GET request. It's a 200 OK, and there is some data that was transmitted. So this is in the ASCII format. Now, So normally for these CTF challenges, the flags are in a specific format. So for Pico CTF, it is in the form of Pico in lowercase and CTF in uppercase. Now, if you will see here, it resembles very similar to Pico CTF, but although the alphabets are different, right? So this is something which is very common, wherein we use something called a lot of these challenges use try to mask this data, right? So in this case, what it seems like it is a substitution cipher wherein P has been replaced with C, I has been replaced with V, and C has been replaced with P, right? So it's more like a substitution cipher. So one of the very common substitution cipher is ROT 13. So let's see if I can get ROT 13. So I'll just search for any Route 13 decoder. Okay, let's put it here. Once it decodes this Route 13 decode, it gives me this flag. I can just simply copy it and paste it here, and it will be submitted. If it is correct, it will show you that it is the correct flag. So this is one very basic example on how you can utilize, how you can use your Wireshark, whatever the you can extract that data from the capture and you can use it. Now, there are a few more things which you can use through Wireshark. Let's try to see if we can solve one more challenge before we move on to the Scapy part. Let's say TFTP forensics. Okay. Now, this is another thing which this is another capture file from the same CTF challenge. Now here also there are a bunch of packets. Now what I can see is that they are all TFTP packets and it has transferred some files. Now if I have to look into all the transferred files in these capture, Wireshark provides a very good utility which is export objects. For a specific protocol types, let's say for HTTP, for TFTP, for SMB, it provides an opportunity to directly export the data from here. So if I'll just do export from there, it will list down all the files that have been transmitted and which are seen in this capture file. Right? So if you see here, we have an instructions.txt file, one plan file, you have a program.deb file, then you have a few image files. If you want, you can simply save all of them in one go. If you do save all, it will save all of them in a single go. Or what you can do is you can save any specific file. So in this particular case, we can save all of them. Let's say save all. I've already saved this file. So this is how what it will look like, right? Okay, so this is what it has saved. So one is instructions.txt, one is plan, one is program.deb. Right? So if I look into the instructions.txt, this also looks jumbled. Again, we can utilize the same ROT 13 decoder to see if it helps. Then you have something called as plan. This also is jumbled up. We have to find out what cipher or substitution cipher is being used. And then you have a file. This file is program.deb. Now program.deb, so Debian provides some packages through which you can look into the details of the file. So if I look into deb, I Now, if I look into the details of this, what it will show me is that it's a Debian package and it is using a package called steghide. Steghide is nothing but a steganography wherein you hide certain data in the picture. So I will not go into the details of steghide and all, but this is the way how you can identify. You can from the Wireshark, you have extracted this data. Now, further, you can look into the details of this data, try to find out what type of information you are receiving in that file. Then you can use these utilities like this in order to extract the data. So just for completeness purposes, what I'll do for the stack height. So once you use ROT13 decoder, it will give you what exactly was the content of that particular instructions were there. And on the basis of that, what you can use is you can use stack height to extract. Stack height is basically extracts any data which is hidden within the images, and it extracted and gave me a flag called flag.txt. Once you see flag.txt, it will give you the exact flag. So I'll not go into the details on how you can utilize all this, but this is just for an understanding that how you have extracted the data from the Wireshark and how you can utilize it further. Right. So with that, I'll move on to the next section. So the next section is about Scapy. So Scapy is a very powerful tool. It's actually it is a tool for packet manipulation, and so you can craft a packet from scratch. You can launch an attack from scratch. When I say launch an attack, don't launch an attack to anyone on the internet. Whatever you are doing, whatever we are teaching here, it is just for learning purposes. We don't expect you to do anything. So you will be responsible for whatever you do. Right? There is nothing that we are only teaching you for educational purposes so that you can use it for better purposes. Right? So this is a tool which is used for packet manipulation, and it is very easy to install. Right? On your Linux box, you can simply do sudo apt install python 3 Scapy. Very easy, and there is no. In fact, there shouldn't be any theory on this. Let's directly go into understanding of the Scapy. Right? So in order to launch Scapy, I hope my screen is visible. I'll just increase the font a bit. You can just launch Scapy. Okay? And this is how Scapy is launched. Right? Now, let's say I have to create a packet. I have to create a packet from scratch, right? What I can do is I'll just create a, let's say I created an IP packet with TTL of 64. If I look into the packet, it will give me an IP packet with a TTL of 64. Now it doesn't have any IP address or anything, but this is how easy it is into just add a field to a packet. You can simply do IP TTL 64 and it will create a packet which has an IP, has an IP header, and that has a TTL value of 64. Now let's say I want to add a source also. So SRC is nothing but one of the parameters in the IP header, which is the source address. So let's say I want to add 10 as the source address. Now if I look into A, it will show me that IP, it's an IP packet, the TTL of 64 and a source IP of 10. If I put in a destination as well, right? Let's say 10.20.10. Now if I look into the packet, I can see an IP packet with a source of 10 and a destination of 10.20.10.10. Now, if I have to send it over the network, that is also actually very simple. I'll put in a Wireshark as well, just to, so on the left hand side, what you see is the CLI of that same machine. On the right side is the UI of the same machine, right? So let's, okay, so this is the port. I'll just put in a filter first for 10.10.10.10. Okay, and I will start capturing. And over on the left side, and just send one packet. Let's see if we have captured it. Yes. So if you see here, we have sent a packet with just 4 commands, right? A very simple commands. I have created a packet and I have sent that packet onto the network. If you see the IP header, the source address is 10.10.10.10, destination is 10.20.20.20, and the TTL value, if you see here, For the IP header, it should be 64 because that is what I created when creating the packet. So with a very simple command, you can actually craft a packet and you can send it across. Now, when I'm doing that, right, I can still be identified on the network. So I've spoofed the IP address. This is not the IP address of my machine. So if I have to look into the IP address of my machine, if I do config, my IP address is 10.197.224, but I have spoofed the packet with a completely different IP address, and the destination is also completely different. Now, but I can still be identified on the network. Why? Because my MAC address is still the same. I haven't changed the MAC address. So what I can do is there's a different, what do we call, there is a different command if you have to send packets at layer 2, which is send P. So send is something which uses layer 3 information. Send P is something which uses layer 2 information as well. Now, if I have to send a packet, let's say I'll do ether. So I added this source port, then I'll just add an IP of SRC equals to, let's say, 10, 10. 10 or 20 or 10 or 10. Okay. Now I have to just send this packet. Let's see, let's put in start the capture again. Now you see here, if you see here the layer 2 information, now the MAC address is changed to AABBCCDDEFF instead of the actual MAC address which it was sending previously. Now, very simply, if I have to just send 1,000 packets, right? I just simply change it to count 1,000. I will put in a capture again. I sent 1,000 packets same instant. And if you see here, it is filtered with the IP address, the displayed packets are 1,000. So in an instant, I was able to send out 1,000 packets with just a single line command, right? So it is very powerful in that sense, right? Not only this, it actually allows you to sniff the packet also from the network, right? So let's say if I have to sniff ICMP packets. So when I say sniff, basically it is able to read the packets from the network. Let's say I am sniffing, let's say I just want to read 10 packets, right? 60. I see. Okay. So now I'm sniffing 10 packets. So what this says is sniff count 10 means I'm sniffing only for 10 packets on interface. This is the interface which is available on my machine and with a filter of ICMP. So I'm just filtering ICMP packets and I will stop after 10 packets, right? So it is sniffing here. Now at the same time, let's initiate a ping. Let's see ping. Now it is sending ICMP packets. As soon as it finishes 10 packets, this will automatically stop. Now, if you do ICMP packet here, it will tell you that what are the different packets which have been sniffed. TCP 0, UDP 0, ICMP 10, other 0. Okay. If I have to look into the details of the individual packet, what I can do is ICMP packet 0 dot show. Right. Now it will tell me the details of each and individual headers. Right. For ICMP header, what is the type of the request? So this is an echo request. For IP header, what is the source and destination, right? For Ethernet, what is the source and destination? Right? So this way you can create your own custom packets and it can also help you basically launch an attack as well. So let's just see how we can do it, right? Let's say I want to do something called as port scanning, right? Now for port scanning, so let's say for a specific IP address, for a range of port I want to scan, right? So how this can help me is, so let's say TCP scanning. So destination address is, so I have a server, I'll just scan that one rather than bringing down anyone else. Right. So at IP layer, it is this. At TCP layer, what I can do is flags sync comma t equals to 1 to 1024. Okay. Now what this will do is it will create a packet. It will create packets with this information for going at layer 3. The information will be destination IP 10.197.225.18. TCP will have a flag, a SYN flag only, and it will go for destination port from 1 to 1024. Now, if I just do send of TCP, and at the same time, I'll just put in a capture. Okay. Now, if you see here on the network, you see it sent out all these TCP requests on different ports. So this one, if you see destination port 922, 923, 924, 925. So it loops into that port between 1 to 1024. It will send out all those requests to the server. So basically you can create, if you can get more information using the simple tool like Scapy, you can get information about the entire things on a network, what ports are open, what are the IP addresses that are responding. You can look into those things and you can basically craft your next step, right? And what to do. Now, with this, it's so for Scapy, so let's have a look at maybe I'll just show you one more attack. That way things will be. So there's something called a Smurf attack. So what Smurf attack is? Smurf attack is another DDoS type of an attack. Now, in a Smurf attack, what happens is when a TCP packet goes over the network, right? There are specific flags that can happen, right? That go, right? So let's say if it's the first packet, there will be SYN packet. If it's the response, there will be a SYNAP packet. So in Smurf attack, what is done is that certain flags are added together in a TCP packet such that the TCP stack on the receiver side, right? Whoever is receiving those packets, they are not able to, if they have a flaw in the processing logic, it can create a DOS kind of a situation. That means it can bring down those servers, right? So let's say for Smurf attack, I won't send it, but I can just show it to you, something like this. So this is, sorry, sorry. What I was talking about was an Xmas tree attack. This was not a Smurf attack. For a Smurf attack, what it do is that we send out an ICMP broadcast echo request. And in that we spoof the source IP by using the victim's IP address. So what it does is that it receives a lot of ICMP echo reply from many sources, and that kind of overwhelms the server. So again, I'll not launch it, but I'll just show you how you can just simply craft it. At layer 3, you can just craft the information of source IP and destination IP. And on the ICMP side, you can just specify what type of ICMP code and reply to use. Now, with that, let's move on to the next part, which is Nmap. So Nmap is another very powerful, it's also an open source tool. Now, how Nmap helps you is basically it helps you scan the network. Now, when I say scan the network, basically it tells you what are the different IP addresses which are alive on the network. What are the different ports that are opened onto the network, the TCP port, UDP port. What these port scanning capabilities, what it helps you is, let's say, if there is a vulnerability that is open or that is applicable only for a specific port, let's say a vulnerability which affects only FTP port, and if that port is open on the network, then that vulnerability can be exploited. So as a defender, you have to ensure that you patch that. As an attacker, you know that that is something which you can exploit. Apart from that, there is something called as OS fingerprinting. Now, operating system fingerprinting helps you understand what is the operating system which is being used. Let's say in an environment you have Windows Server being used, or a 2016 server or Windows 2012 server. And there are some vulnerabilities which are very specific to those servers. So this OS fingerprinting will help you launch those specific attacks. And apart from that, it can be used in all the scripting and automation. It provides a very nice report which tells you what ports are open, how it is open. And before we move, I just want to show how what are the different. So let's say when you are launching in Nmap, when you are doing a TCP scan, what are the different things that will happen, right? Let's say you sent a SYN packet, right? And there is a firewall from the client to the server, and there's a firewall in the network which silently drops the SYN packet. This is what is reported as a filtered port in the Nmap scan. Then a closed port is something where a SYN packet goes through, but in response to that SYN packet, there's a reset packet being received. Now that reset can be sent from the firewall, or that reset could have come from the server side, but that is considered as a closed port. And the last is the open port. Now this open port is when you have a SYN-ACK. For a SYN request, when a SYN-ACK is received, that port is considered as open. And we close that port using a reset packet, right? So client itself will close that port, the Nmap from where you are running it, that will close the port using the reset packet. Now let's again go into the detail. Let's say how we can run the Nmap. Okay. So Nmap has a lot of options. So I've added all those details in the PPT, which will be shared, but I don't want to go through all the different options. But what you can do is that you can run Nmap for a. So this is basically a SYN that will be sent. Let's say I'm sending it on one single IP. You can basically specify the entire network if you want to scan. But for now, I'll just scan one IP. Which is basically the gateway IP for my machine. So it takes some time. So overall, this Nmap is a bit slow. It takes time to execute because it has to run through all the ports. It has to gather all the information. But once this run is complete, you will see an output similar to this. So this is the same scan which I ran yesterday for this, and I captured the output because I knew that it will take time. So what it does is it sends out request on a different port. And after sending out request on the entire port range from 1 to 65535, what it identified was port 22, port 80, and port 443 are open. What are the different versions which is being used? So let's say for SSH, what is the SSH version being used? For port 80, what is the actual web app server being used? So it gives you that type of information, that much detailed information. Coming to so there's another type of scan which is called as the operating system scan. Now in operating system scan it's Nmap-O, capital O. What it will do is that it will try to identify what is the operating system. So in this case, if you see here, it is running Cisco IIS 12.x. So this gives you an information that what type of an operating system is running. And now if you Google it out, find out from the product documentation, find out any vulnerabilities on that specific version, then those can be exploited. Right? As a defender, you know that these are the type of vulnerabilities which you have to use which you have to work against in order to prevent the problem from happening. Now with that Nmap, so I have added all the details. What are the different flags which will be used within the Nmap, like as small as capital S is the TCP port scan, what is the connect port scan, UDP port scan. All this documentation is very easily available on the internet, so you can just go through it and get a better understanding on how Nmap works. Now, so this is a challenge. So whoever is interested, you can just try it out in your spare time. You can just try to create your own Nmap. So now since we have studied, I've given you an overview on Scapy and an overview on Nmap. You know what Nmap does, you know how Scapy works. Can you create your own Nmap tool using Scapy? See if you can take this as a challenge. Try to build your own tool. You may take help you may Google out the things, how stuff works, and then you can utilize it and use it for your learning in order to create that. So that way you will understand what are the different uh, configuration options and everything will be, what are different configuration options available for Scapy, what are the different configuration options on Nmap, how you can combine both of them together and um, create your own tool, basically, right? Um, with that, it's almost end. I would like to just go through one more challenge. This will be the last challenge before the end of the session. So this is again a CTF challenge here, which is this one, Wireshark 2, right? So the reason why I'm showing this to you is because at the end of this, there will be a CTF. So all these learnings might be useful to you on what all information you can use, right? So over here also, if you see here, it says, can you find the flag? And it gives you the file. Apart from that, it gives you two hints also. So before looking into the hint, let's see if once we download the file, what are the different informations we see in that file. Okay. So this file is shark2. Now coming into the file, so first, let's go under statistics, protocol hierarchy. We see again different protocols. So within IPv4, we have UDP, then we have TCP. Within TCP, we have TLS and HTTP. So again, there is a lot of HTTP packets which are going through. So let's see if we can just filter using HTTP again, and if that is helpful. Right. Now, if I look into the HTTP, right, again, it shows me a lot of this, and then some encrypted packet. Then I see a get, and then I get again a 200 OK. Now, if I look into 200 OK, let's follow the stream. Let's see if we can get anything useful. What it says is the official red shrimp herring website is under construction. Please check back later. Right? This is the only information I get. So definitely this is not the flag. So let's look into the other flags, right? Let's again filter using HTTP, see if we can get something else. So this is all encrypted. The 200 OKs are all encrypted. Let's scroll down a bit. Okay, I got something here. It says get flag and then 200 OK, right? So if I go into 200 OK, I'll just, let's follow the TCP stream, right? Now it gives me this flag, right? It looks pretty easy, right? Because I'm immediately able to get the flag. Let's see if this flag works. Right? It says, sorry, that flag is incorrect. So although it shows into the same format, but these are some of the diversions which are created in a CTF challenge. Let's see, apart from this, we have anything else. So we have get flag here. Let's see, do we have anything else? Let's use the URI, request URI, and just apply as filter. Select it. Okay. And if you see here, there are a lot of get flag requests. Now, if I'll go to any one of them and just do a follow TCP stream, this is a new this is a new flag, right? So then I'm definitely sure that the flag is not there, because the flag, it is not there in this plain sight. There is something else, right? But if you remember, the first thing which we said is that it said that this website is under construction. So there were, when we did the protocol analysis, so protocol hierarchy. So we had DNS and we had TCP. TCP, HTTP we have already looked. Then we have TLS. TLS we know is encrypted. Quick is also a protocol which is encrypted. So I'll just skip that for now. Let's look into the DNS part, right? UDP.port. The DNS is UDP 53. And if you look over here, there's something very strange that you'll see. So there's a lot of that is connection that is happening on this red shrimp herring, right? A lot of requests. And if you remember in the first follow stream when we did for the 200 OK, it says that the website is under construction. So it's more like a hint that what you can do with this, right? Now, if I look into this, it's more like, let's say, so all of these requests are going to 8888. Now, let's say I don't want to see the packets which are going to 8888. I want to look at to the packets which are not going to 8888, something. Okay, so now if you see here, now I have filtered the packets which are not going to 8888 because 8888 look to be the DNS server. It's a global DNS server. But this website doesn't look to be a global DNS server. But there is a lot of DNS requests which are going to 8888. If you look into this, so again, there are queries which are going. And then if you look, so what the query name here, it gives me an indication that there is a combination of, it's more like a data exfiltration attack. Now in data exfiltration attack, what happens is you use different protocols in order to exfiltrate some data. Now this equal at the end, what it signifies is it's more like a base 64 encoding mechanism which is used. So now what I can use is through this. So you'll have to spend some time on this to better understand this. Now, what I can basically use as a filter is if I have this, I'll just say this. Okay. I've just filtered for DNS request going from source this. Now it gives me a much more. So if you see the same packet is being repeated thrice, but there is same data. So if I concatenate all this data, maybe I may be able to get the flag. So this is where you can either do it manually, right? So let's say if I look for this DNS query. Okay, let's put one more filter and DNS dot. Copy filter. So instead of equal, I'll just do contains local. Okay, rather than doing everything. Okay, so that way I have just narrowed it down to a few requests, right? So all these requests, now you can use, so this is again, you can use that as a task. You can use Scapy in order to filter these first these first few data before the dot, concatenate it and use a base 64 decode, or you can manually do it, right? So there are two options. You can use Scapy, you can do it manually, whatever way you want to do it. But basically at the end, what this basically is, this is the base 64 decode. I have decoded it manually as well. So this is once you concatenate all that data, it will show up like this, and you can just do a base 64 decode and it will give you a flag. And then you can utilize this flag, copy it on the this, you can submit it. So all these challenges, you spend some time, try to identify what are the different things which are being exchanged, utilize Scapy. So I basically use Scapy in order to extract that DNS, the host name for the DNS. And then I use that in order to concatenate that. Because right now there are few packets, but let's say if there is a lot of packets, right? How will you do that manually? So that way you can speed up the process. With that, I think that was it from my side. So there are a few references which you can utilize in order to learn this. And with that, I would like to say thank you. If you have any questions, you can just, and if you'd like to ask something, please feel free to ask. I'll be happy to answer.
Yeah, thank you. Thank you very much, Akshay, for delivering the first webinar as part of this masterclass series for the CTF. There are a few questions that are popping up in the chat box, but before that, we've got a request from participants that you please show the last two slides of your PPT once again. So can you just do that?
Okay, I'll just show it. Is it the reference link which everyone wants?
The reference and the one before that.
Okay.
Okay, so here, dear participants, you have seen the last two slides of his presentation, and I hope you've taken the notes. Yeah, he's just showing the references once again. You can take a screenshot if you want. Okay, so there are certain questions in the chat box. One question which is popping up is, what is 200 OK?
Okay. So for that, a more detailed discussion on HTTP will be done in the future sessions. That will be done by Karthik and Prapanch. But just for your reference, so 200 OK is basically a response code. It is a successful response code. So HTTP works on response code. So you send out a request to an HTTP server, and in response, it sends back the data. So that data which is sent back, so if it is a successful transaction, you receive a 200 OK. If it is an unsuccessful transaction, there are different other status codes like 400, 500 error code. So that those will be sent. So 200 OK basically for HTTP, it signifies a successful transaction, that the data has been transmitted successfully.
Okay, so thank you. And here's the next question. What are the preventive measures or how to identify those IP addresses that are getting masked?
When you say masked, are you talking about when we generate the traffic using Scapy?
Yeah, so Om, can you please specify that? Is it about what the ones that you're getting when you generated it using Scapy? Which IP addresses are you referring to? You can type it in the chat box, please. Yeah, so he says yes, the IPs that are getting masked using Scapy. Yes.
Okay, yeah. So there are different mechanisms, right? There are different security settings which are applied onto the firewall. So one of the very common is what we call as the reverse, the RPF check. The RPF check is the reverse source routing. So what we do is that we validate whether this particular IP address actually resides beside this interface or not. So there are different security mechanisms, different security checks that are applied at the network level, which takes care of such problems.
Okay, so the other question that has come is about I'm using Windows, so do I need to use dual boot for Linux?
So if you want to install a Linux on Windows, and then there is a Windows subsystem for Linux that is available, they can utilize that. You can just Google on that, WSL, and you can use that.
How can a particular person who's interested in this exercise remember all the status codes?
You don't have to remember it. So everything is available online. So that is the best thing, right? So earlier people used to search through books in order to get the data. Now you have everything on the internet. You just go ahead, type it on the internet, you will get everything. So you don't have to never memorize all those things. It is all about, you just know this so that you know at the right time you have to search for it. What if you know the concept, you don't have to memorize the code. Just remember the concept and everything else will come with practice.
Okay, what is the difference between UDP and TCP?
Okay, so UDP and TCP, they both are layer 4 protocols, but TCP is basically a connection oriented protocol. So by connection oriented protocol, what we mean is that it creates a connection, it creates a stream. Okay, so let's say I have to transfer 1,000 bytes of data from one machine to another, right? So there is a flow control that is established. Let's say there is a link issue in between, and because of that, few packets got dropped. So TCP has that capability to understand that there were few packet drops, and then it can recover, it can request the sender to resend those packets. Whereas UDP, it's a connectionless protocol. Basically, there is no stream control that is available there. If some data is dropped, that is dropped, right? So, but there are instances wherein you must use UDP. So let's say we are in this WebEx session. So this audio which is going through, that has to be UDP, right? Let's say in between there was a network fluctuation. It is better to drop those packets rather than resend those packets so that you hear my audio twice, right? So there are instances wherein you want to use UDP, there are instances where you want to use TCP.
Okay, thank you. So I'll just answer the next question from Tajdar Alam Ansari. Do we have to do the Scapy challenge now? Well, Tajdar, you don't have to do it now, but you have to practice it when you reach the actual CTF stage. Right now, what you need to do is the assessment, for which we will be providing you the link shortly. Okay, so the next one is it's a general question, I think. Which is a better tool, Nmap or Wireshark?
So they both are completely different. So Nmap is basically used to uh, understand about the network. You send a packet, you um, get the information, you get receive the response. On the basis of that, uh, the Nmap tool takes the decision whether that port is open or not, and then you can utilize that information for further security practices. But with what Wireshark does is Wireshark helps you capture the packet onto the network as well as analyze those packets on the network. So both are different things. Nmap traffic you can capture using Wireshark and see how those packets are sent. So Nmap is a utility to send traffic. Wireshark is a utility to capture that packet and analyze that packet.
Okay. So can you suggest any decoder and can it make our decryption easy?
What type of decryption are you looking for? There are a lot of decryption, so yeah,
Okay.
so
Sheikh
we need to
Mohammed,
be
can you
specific.
please type in the chat box what type of decryption you're looking for? So let's move on to the next question in the meantime. How do you identify the encryption protocol like ROT13 and hashing protocol used just by looking at the text?
Uh,
Are there good clues?
Unfortunately, no. So it all comes with practice. You have to try it out. You have to try out different decoders online, and on the basis of that, you can decode it. Rod 13 is something which is very commonly used in such CTFs. That's why I've shown it. But that was just for an example. It can be any Caesar cipher. It can be any rotation.
Okay. Why do you use only HTTP protocols to check the flag?
So this particular request, when I looked into the analysis of the captures, right, there were only HTTP packets, and the other ones were UDP packets. So I initially tried out with HTTP, and that is where, because HTTP is generally used to transfer data. So that was the reason I started with HTTP.
Okay, so is it possible to decrypt HTTPS traffic as well?
Um, if you have the keys, so there are two things to it. So if it is going over the network, right, you capture an HTTPS packet, but if you have the session keys, you can decrypt those packets using Wireshark. So it is possible that you can decrypt that using Wireshark, but you need to have the session keys.
Okay, so we have the next question from Shivam, who is asking us how to scan filters port in Nmap.
How to scan filter. So also for Nmap, there are a lot of options. You don't need to remember all those. Just Google what you want to do with an Nmap. There are a lot of tutorials which will give you what are the options which you use in the Nmap to use the Nmap. So never try to remember those Nmap options. Just Google it out and get it done.
Okay, how do we identify the SEE of the base 64 format?
So for base 64 format is something which is it usually ends with a single equal or a double equal, right? That is one of the indication that it's a base 64 format. So at the end you will see an equal.
And from where can we get the capture files?
When you say capture file, which capture file are you for?
Yeah, so can you please specify which capture file?
So if the capture file which I showed here, um, the capture file which I showed.
Yeah, we request all other participants to please mute your audio.
So the capture file which I showed on this session, they are all available on Pico CTF. Yeah, I have added that link in the references section. So you can go there, you can go through the challenges. All these capture files will be available there.
So dear participants, we hope you took a screenshot of the reference links. They will be very useful for you as we go along, as we move towards the different stages of the CTF. So the next question from Soham is that we saw both IP address and MAC address can be spoofed. So what is the unique identifier that cannot be spoofed by an attacker? And in case there is none, then what are the strategies that a defender can use?
There are switch level security capabilities that are available. So there are things like .1x, there are port security available. So all those things at a network level will help you prevent such type of attacks.
Okay. To decrypt the hash file, what, uh, yeah, okay. So how do you decrypt the hash file?
So hash file, so hash is a one way. So until unless that algorithm is broken, you may not be able to decrypt it.
And how does one know that a message was encrypted as base 64?
So base 64, as I mentioned before, right? So if base 64 messages usually end with a single equal or double equal. Um, so that is kind of an indication that it's a base 64.
Okay. Okay. Well, although you mentioned that hash is a one-way thing,
Mhm.
someone has asked how to decrypt hash file. Would you use PW dump or John the Ripper?
So I haven't used, so this is more in terms of the memory forensics. So that will be, those details will be covered in the next section, in the next details. So just wait for that next session, you will get those details.
Yeah, so we can see some discussion regarding the prerequisites required to be, met if one is looking for a job at Cisco. I would just like to reiterate here to all the participants that this webinar is more of an intellectual exercise wherein the technical expert is sharing his experience and his knowledge and helping you gain some skills. So if you focus and develop those skills and work hard, you would be ready for a job in any good company. So please refrain from having such discussions in the chat box, and please pay attention to what the technical expert says and pay more attention to the exercises that he is given, which will help all of you in any interview that you'll attend. So please don't spam the chat box with, uh, what could be the possible requirements for a job in Cisco. Okay. Okay. So the last one, cracked station is NIE but does not decrypt salted hash. What could
So
that be? Yeah.
So it's again is another part that will be covered in later section. So just uh, wait for now. Let's focus on network forensics in terms of what um, we have covered today, because I don't want to get into the details on the tools which were not a part of the session. But all these things on how to use those tools from the memory forensics perspective, all those things will be covered a bit later.
So, okay, let me take another couple. One is brute force take a long time to decrypt and need high GPU for shortening time.
So So again, it is related to breaking the password. So yeah, brute force attacks do take time. right? Because so that's where you need to have a very solid library in order to dictionary in order to generate a brute force attack.
If two computers or servers are configured with the same IP and I request information from that IP, would I be receiving any response? And if I as an end user receive any response, can I just spoof that IP address and steal the information?
Okay, so that is one of the way you can create a DOS for one of the devices. You can spoof that addresses and ensure that that information is received to you. Although the connections may not be complete, but you can still receive that information and make something out of that information. Again, so there are ways to prevent that on a network, but yes, having spoofing someone else's IP and using that on a same network uh, will help you gain some and will help you receive some packets which were just supposed to be received by the other machine.
Okay, so with that, I would like to thank Akshay. Akshay, it has been an extremely informative and you've done a very good job of kicking off this series of Digital Defender CTF 2023 Masterclass webinars. And as much as you have informed the participants, I think you have left them with that little tinge of curiosity too, which is required for them to complete the exercises that you have given. So on behalf of CySecK, we would like to thank our technical expert from Cisco, Mr. Akshay Dubey. Thank you very much, Akshay.
Thank you.
And dear participants, I will now be pasting the link to the assessment in the chat box. We will also be making this available to you, to those who are seeing this live broadcast on YouTube, on the CySecK's YouTube channel. And it's now 5:31, and this link will remain active till 6:31. So you've got 1 full hour to attempt this. It's 19 questions, not very long. If you have listened to what the speaker has presented with attention, you should be able to score very high marks quite easily. Please attempt all questions and please share this with your friends who have attended this on YouTube, whom you know are attending it on YouTube. And we will close this at 6:31 p.m. So thank you very much. We hope you copied the link. We will remain online for another 5 to 10 minutes. Akshay, if you want, I think you can sign off.
Okay. Thank you, sir. Thank you, everyone. Thanks for joining in today. And I hope you have learned something. That was the end goal, that it's not about just doing the presentation. It's about ensuring that you get something out of it. And if you have anything, just feel free to uh, reach out if you have any
Yeah,
doubts.
just one instruction for those who are taking the assessment, please ensure that once you open the form, there is a field called email address, wherein you have to enter the email address which you have registered for the CTF, so that we are able to track your scores. Okay. So thank you again, Akshay, and we will see you later during the course of the CTF.
Thank you. Bye bye, everyone.